Hello, everyone. So today is the day. Today you have your quiz, and I'm going to just take a moment to go over your quiz, to go over the instructions, and to do some examples. But the first things first, let's see our quiz. And there's going to be just one slight difference in this quiz. I will normally give you a Google form with the quiz, but not this time. For some reason, I just had a lot of trouble with my Google Forms, and it was very, very difficult for me to digitalize this quiz. So this time, I'm not gonna give you a Google form to fill out. And you're gonna tell me, Miss Oliveras, then how are we gonna send you this quiz? Well, it's very simple. At the end of your quiz, I always try to add some instructions. Instead here, that it must be sent by email. It says send by email with your student's name, with the student's name, with your grade and the date in the subject area of that email. You must show the procedures on that paper that you're sending me. The acceptable format is PDF only. Now, why only PDF? Because I am planning to print them. So please try to send them to me as pretty as possible, as more clear as possible, because what I am going to do is when we start school, now this week, I'm just gonna print all the tests or the quizzes, and I am going to check them by hand. Let's see how it goes. And again, failure to show your work will automatically be grounds for the failure of that exercise and therefore the test. So remember, you must show procedure as much as you can. Now, I know when something is easy and you may not need to show procedures, but I do also know when you must. So please be vigilant. What is the instruction? The instructions are very simple. It says evaluate each expression and simplify. Show procedure. And again, in the first part, you're gonna have a lot of negatives exponents, a lot of zeros exponents. You just have to solve each of those um, expressions, right? Each of those expressions. And again, you're gonna choose A, B, C, A, B, or C in each one of those. And I know they look like a lot, but if you look really, really closely, you see that they're pretty easy. And in the second part, again, you're gonna evaluate each expression and simplify, but this time you're gonna have rational exponents. And you're also gonna have roots or radicals, right? Like we like to call them. At the end, you do have a bonus. And again, this bonus is 10 points each, 5 points each exercise, and you must show the procedures for me to give you those points. You're going to have until Wednesday, March 24th to send me this by email. So let's do some examples, okay? So let's do some examples. In the first part, and all the part says evaluate each expression and simplify. So very simple. Let's go through some of the rules. Remember, I'm going to try to do this in colors, that if I have an exponent that is negative, to make it a positive, all I have to do is put everything over 1 to make it positive. If something is to the 1, remember that is the same thing as the base. Simple. Now, what if I have a negative in my base? Well, simple, you just have to flip it again. And then you're just making it a positive. Now, another rule, what if you have a 0 exponent? If you have something to the 0, you know that anything to the 0 is going to be 1. It doesn't matter the number or the variable, everything to 0 equals 1. Now, there are a few more rules about exponents that we normally use. For example, if we have exponents that have the same base and they're being multiplied like this, then we only have to add those exponents, right? That's going to be the same thing as 3 plus 2. That's going to be x to the fifth power. Now, if we were dividing them, then all we have to do here is subtract 3 minus 2, and you know that that equals 1, and everything to 1 is just the base. Now, what happens if one of those exponents gets to be negative, right? What if the denominator exponent is smaller than the denominator? Again, you're going to put the first one first, denominator first, then you're going to subtract the denominator exponent, right? And here you have a negative number, x equals -1. Now to make it positive again, all I have to do is put it over a fraction bar, and then my x, or my variable, or my number, depending on the exercise, is going to be positive like that. Another thing that we like, another, another rule, right, that we have been talking about during our classes is, what if I have a base and an exponent that is raised again to an exponent? So for example, if I have x to the 2 to this raised to the second power there, and all of that is raised again to the third. If it's something like this, all you have to do is multiply your exponents, the same base, and again, it has to have the same base. 2 times 3, that's going to be 6. Now, we also were talking about rational exponents. And rational exponents are just, again, exponents that have a fraction. So for example, if we have something like this, we solve it with roots, right? Or radicals, like we like to call them. And in this case, because it's a 2, all we need is a square root. And remember that there's an invisible 2 there. And this is the same thing as this. Again, I don't have to write that number 2 because it is a given. If it's bigger than 2, like 3 or 4 or 5, then we write it down. For example, if I have x to the third, then that is going to be the cube root of x. There, I wrote it down. Let's see, let's do another. So let's do some exercises. Let's do some examples. Those were just the rules, the general rules, right? So for example, if I have a number raised to the -3, for example, 10 to the -3, how can we solve this? Well, all I have to do is put it over the 1, and I'm making that exponent a positive 1. And then I can solve, right? This is the same thing. Remember that is an exponent is when we multiply that base over the number of the exponent. It says times 3. So this will be 10 multiplied by 10 multiplied by 10. You see it? Well, this is going to be 1,000. 1, 2, 3. Very well. 1,000. 1 over 1,000. How about if I have, and again, we already did this one, x to the -1. We just put it over. If I have x to the 0, and remember everything to the 0 is 1. Let's try to do another one. How about if I have something like this, 3y to the negative 2. Now, the negative 2 is not with the 3, it's only with that y. So the 3 is going to stay up. Remember, I can also divide this into two different equations. So it can be 3 and y negative 2. And how will you solve this? Well, the 3 is already positive, so it will be 3. It stays in the top. And the y is the one that I want to change. And then I can just multiply this, right? 3 and 1 times 1 equals 3. And I can make this a fraction too. And 1 times y to the second power will be y to the second. And that will be my answer. Now, what if I have something like this? 2a3 over b negative 1. Again, the 2 and the a3, they are already positive, so they can stay on the top of that fraction bar. And for me to change that b to the negative 1, all I have to do is send it to the top, right? I'm just going to have to send it to the top to make it a positive. And if it's into anything to the 1 power, again, is the same as that. So I'm going to have 2a, 3, and b. Now, why don't I add the exponents of 3 and b? Well, because they have different bases. And I can only add the exponents if they have the same base. If they have different base, I cannot add them. So if I have a3 times b2, then it stays as b3, a3, and b2. I cannot add those exponents, right? They have different bases. That was just a reminder there. Let's try something different. What if you have, and this is more for the second part, now we're going to go to, rational exponents and radicals, right? So now, what if you have, so I just said an ugly rational, a radical. What if you have something like this? Now you know that you can change this into a fraction, right? Into a rational exponent. Remember that there is an invisible 2 right there. If I'm not giving you that 2, if I don't give you any number, just remember that there is always a given 2 there. Now, what if I have, instead of that, what if I have something that looks like b to the third? Now that I can change into a radical 3 over b. So you can see that you can go this way or you can solve that way. And you will have the same answer. Now I'm going to erase those two. And we're going to do some more exercises. What if you have, what if you have something like this? This is a cube root of x9 times y3. Now, I always have told you that when in doubt, always separate them, right? Now, some of you, I know you can do this mentally, but if you are in doubt, you can always separate them. Now it's easier. Now I can change them into rational exponents. And again, I'm going to multiply by the cube root. That will be 1 over 3. And the same thing with the y. Y is going to be y to the third. And the cube root is going to be a third. Now it's easier, right? I can solve that multiplication there. So in case of the x, it's going to be 9 over 3. In the case of the y, it's going to be 3 over 3. And how much is 9 over 3? 3. And how much is 3 over 3? 1. Again, you can do that mentally, but I always like to show all the steps. So there you have an example. Let's just do one more example. What if I have something that involves um, rational exponents instead of radicals? For example, what if I have something like this? 2 to the 16, we go 216, sorry, um, elevated to 2/3. Again, I can split, right? I can split that multiplication. I know that 2 over 3 is the same thing as 2 times a third. So I can do the same thing with that exponent. It's going to be 216, 2 times a third. We go 2 times 1/3. Now I have showed you that I can use parentheses so I can know what I can solve first and what I can solve later. So you have two ways of solving this. You know the typical way. That means that you can do I'm going to do the typical way in yellow. So the typical way, and I think is the hardest way, is just do the cube root of 216 to the second. Now that will take you a little bit more because what is 216 to the second power? That's going to give you a really, really big number. And then for you to find the cube roots of that is going to be also a little bit difficult. So there is a way to make this a little bit easier. And I'm going to try to do this in blue. I'm going to erase this one and do this in color blue. So what I can do is try to solve for the radical first, for the cube root of 216 first. And then I can multiply that by 2. I know it looks scary, but it's a lot easier. What number can I multiply 3 times? That is going to give me 216. Well, I know that 6 times 6 times 6, right? That's going to give me 216. Therefore, I know it was 3 times, so I know that is the number 6. And that to the second power, how much is 6 times 6? 36. And that will be your answer. Pretty simple, right? Now, you do have a few exercises that are a little bit more complicated than this, but it's just a mixture of all of those exercises that we have already been doing or that we already did. If you have any questions or doubts, please feel free to ask me. during the day. Again, I do have class at 1, I think it is. No, sorry. I do have class at 12. So please try to ask me before 12 if you have any questions or doubts with this quiz. Again, it was kind of difficult for me to do the Google form. Therefore, I am not asking you to do it. I cannot give you right the Google form, so you're not going to be able to answer the Google form. What you are going to do is just send me your PDF all nice and answered with all your steps, and just send it as a PDF to my email. Remember to write your name, the date, and your grade in all of the papers and in the email. That means that if you go to an email, and I'm going to show you how I do this in my email. If I go to new messages, here you're going to write my email. You're going to say, sorry, I have a lot of emails there. Eh, Oliveras at Frobel Bilingual School, PR.com. And you're going to put your name, your grade, and my homeroom is A2, and the date, and today is March 23rd. And then you're going to upload. You're going to look, sorry for that. You're going to browse your computer. I'm going to go to my desktop. It's probably one that says Algebra around here. Algebra Quiz 6. Open the file and just upload it. Simple. So, guys, thank you for being with me today here. Thank you for understanding, and I wish you the best of luck. Have a wonderful day, and I'll see you in our next class. Bye.